Hello, so for our shortcomings and wishlist video, I'm just going to reference the document that we have, specifically the shortcomings and wishlist annex. So of the final version of the overall simulation environment, it was initially requested that we actually put together 3 different reinforcement learning algorithms. We delivered 2, so that's dueling DQN and double DQN. Ideally, we would want 3. That was what was requested of us. In practice, there's nothing, strictly speaking, that says it doesn't already work with the other ones, actually. Uh, the environment itself is mostly agent agnostic, so in theory, works perfectly fine. But it was not tested, so we can't actually say that that was feature complete. What we will say though is that if we want to expand at a later time and eventually test other ones, it should be fine. We're gonna have to possibly make some changes depending on which reinforcement learning we actually want to implement. I'll get into that a bit later. But another shortcoming that we had was the reward function itself that we had put together was functional actually, and it did deliver results, but it's uh, a key part of the actual system itself, and we didn't exactly have a very good justification for exactly every one of the reasons why we did the stepwise function that we did. For example, a continuous function might be a better idea based on an interpretation of the memory state. However, as I said, it's a workable environment, but it might need to actually have some further empirical reasoning put into it to maybe adjust the numbers a little bit. Again, it's something that we had planned to do and actually did implement, but we're not calling it feature complete because it's not exactly up to all the requirements that our product owner put up on us. And then as far as the wish list and future development, so as I said, we only ended up supporting, and I should say really testing, only 2 algorithms. If we want to add additional support for algorithms that are not specifically how can I put this, not specific to the implementation that we did. So for example, the implementation that we did specifically dealt with discrete observation and action spaces. This is not the case in DDPG, where DDPG actually does not expect discrete, it expects continuous values. So if we want to support DDPG at a further time, we're actually going to have to update the actual environment itself with some sort of continuous value space so that we can actually support that. But there are plenty of other non-continuous, so discrete action space algorithm implementations, so that's by no means means we immediately have to move to that anytime soon. In addition to that, for the most part, the actual algorithm implementations that we did were part of the stable baselines library, and there's nothing that says that they can't be further modified, either as the stable baselines libraries get updated or as more as we want to expand beyond the stable baselines library to some other ML implemented libraries that have been implemented already. In theory, as long as they are within the OpenAI standard, it doesn't particularly matter where they reside. And then the last one we wanted to get into is that we wanted to figure out if there was some way of doing an easy parameter optimization and results analysis. So probably either do a Python script embedded as part of the environment, or maybe as part of the user guide, we'll put in some notes about how to do, for example, production pipelines that sort of uh, take you from data to output in effectively a single line, and that also support things like cross-validation of parameter optimization. Outside of that, there's probably a whole lot more work that could be done on this, just because it's a fairly sizable reinforcement learning project, and all that, of course, isn't even touching about whether we want to further update the environment to support different hybrid models. Right now, our hybrid memory model is just a certain amount of DRAM and a certain amount of persistent memory. Ratio is we can adjust that as necessary on the fly when we create the environment. But if there's different for example, if there's different hybrid models, maybe not just DRAM and PM, but some other type of augmenting DRAM hybrid memory, then we might also have to make future developments in the environment.